Welcome to CSC 201, Lesson 12.1, Formal Languages and Regular Expressions. So we're going to start with some definitions. An alphabet, which we notate sigma, is a finite set of characters. A string over sigma could be a finite juxtaposition of elements called characters. So we have a finite list of characters. Or the null string, which we call lambda. So the null string is just a string with no elements in it. And the length of a string over sigma, we measure its length by the number of characters that make up the string, and the null string has length 0. And then finally, we have a formal language over sigma. That is a set of strings over the alphabet. Okay, so a set of strings makes up a language. So let's consider a very simple alphabet, sigma. It's just the letters A and B. We're going to define a language, L1 over sigma, to be the set of all strings that begin with the character A and have length at most 3 characters. So we want to define L1 here. L1 is a language because it's a set of strings. Okay, so they're just describing a set of strings here that's called a language. So these are strings made up of the characters A and B. They can have at most 3 characters. So they could have 0, 1, 2, or 3 characters made up of A's and B's. So if I try to list them, L1 is a set of strings made up of A and B. Okay, so I'm going to use set notation, the curly brackets. We could have the null string, right? That has a length of 0. That is included in length at most 3. So that's just the null string. There's nothing in it. Okay, and then we could have strings of length 1. So we could have A, plain old A, and we could have plain old B. And now we're going to consider strings of length 2. So we could have A, we could have A, B, we could have B, A, and we could have B, B. Those are all the strings of length 2 made up of A's and B's. And then finally, we'll do strings of length 3 made up of A's and B's. So we could do A. Then we could have A, B, A, B, A. And then those are all the ways we can have 3 A's, 2 A's, and then if I want to have 1A, I could have A, B, B. And then those are all the ways I can start with A. And then to start with B, I could do B, B, B. I could have B, B, A, B, A, B, or B, A, A. I believe those are all of them. All the strings made up of A's and B's that have at most length 3. A palindrome is a string that looks the same if the order of its characters is reversed. So for example, ABA or BAAB are palindromes. We want to define a language L2 over sigma. Remember, sigma is an alphabet with just the letters A and B in it. To be the set of all palindromes obtained using the characters of sigma. Write down 10 elements from L2. So we're just going to write down 10 palindromes. They didn't mention anything about length here, so they can be any length. So plain old A is a palindrome. Reads the same backwards and forwards. Same with B. Same with the null string. It doesn't really exist, so reads the same backwards and forwards. And then we could have AA or BB. Or we could get fancier. We could do like BAAAB or ABABA. Let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 3 more. ABBA. That's 8. Another palindrome could be B, B, A, B, B, 9, and B, 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 10. 10 palindromes. Okay, so we have some notation related to an alphabet sigma. If sigma is an alphabet, then for each non-negative integer n, sigma to the n represents the set of all strings over sigma that have length n. And sigma plus is the set of all strings over sigma that have length at least 1. So that means it's excluding a string of length 0, so it's excluding lambda. That's why the plus means strictly positive, not including 0. Length, positive length. And then sigma star represents the set of all strings over sigma. So sigma star is really sigma plus with lambda added in. So these are very closely related. Now, note that the string over sigma that has length 0, that's lambda. Okay. And the language E star, sigma star, is called the Kleene closure of sigma in honor of Stephen Kleene. Sigma plus is called the positive closure of sigma. So sigma star is called the Kleene closure. Okay, so here is, again, the simple alphabet AB. And I want to find sigma 0, sigma 1, sigma 2, and sigma 3. So remember, this means sigma 0 means the set of all strings over sigma that have length 0. There is only one. It's lambda, the null string. Okay, so sigma 0 are strings of length 1, that's just lambda, the null string. Okay, sigma 1, that is the set of all strings over sigma that have length 1. Okay, so that would just be A and B. Those are all the strings of length 1 made up of A's and B's. Sigma 2, those are all the strings of length 2 made up of A's and B's. So we could have AA or BB or AB or BA. That's all of them. All the strings of length 2 made up of A's and B's. And then sigma 3, those would be all the strings of length 3 made up of A's and B's. So we could have A, B, A, B, or A, B, B. And then we could have B, 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 A, B, 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 A, or B, A, A. That's all of them. Okay, so now we're going to let A be the union of sigma 0 and sigma 1. So I've got these two written down here. If I take their union, I have the null string unioned with A and B. And if I want to describe that in words, I would call it all strings over sigma of at most length 1, because I'm including length 1 and length 0. So this would be all strings over sigma of at most length 1. And then my set B is sigma 2 union sigma 3. So those would be strings of length 2 or 3. All strings over the alphabet sigma of length 2 or 3. A union B is the union of these two. So we have all strings of at most length 1. So these are strings of length 0 or 1, unioned with strings of length 2 or 3. So we're talking about strings of length 0 or 1 or 2 or 3, which is the same thing as saying at most 3. So this is all strings over sigma of length at most 3. Okay, we're going to try to systematically list the elements of sigma star. They're infinitely many, so this is, we're not going to be able to write them all down, but we will do our best. So sigma star is the set of all strings over sigma of any length. So we're going to start with strings of length 0, which would be lambda. And then we would have strings of length 1, which would be A and B. And then we could write down all the strings of length 2, which would be A, B, B, A, B, and B, A. And then all the strings of length 3, which we did in part A, so I'm just going to copy them. Okay, so those are all the strings of like 0, 1, 2, or 3. Then we would do all the strings of length 4, which I would start with A, and I'm going to write ... to continue in this manner. Writing down all the strings of length 4, and then length 5, and then length 6, and ... Okay, some more definitions. Sigma is an alphabet. Given any strings x and y over sigma, the concatenation of x and y is the string obtained by writing all the characters of x followed by all the characters of y. Think of concatenation as like gluing them together. If you have a string x and a string y, you just pop them together, glue them together. So for any languages L and L prime over sigma, we can define 3 new languages as follows. So we can do the concatenation of L and L prime. So a language L and a language L prime. Remember, a language is just a set of strings. So we have a set of strings L and another set of strings L prime. And the concatenation of the two is when you take X concatenated with Y, such that X comes from L and Y comes from L prime. So we're doing a concatenation with a string from L and a string from L prime. Then the union of L and L prime is just the set of all x's such that x is in L or x is in L prime. So we're just putting all the strings from L and all the strings from language L prime together into one new language that contains all the strings from either. And then we have the Kleene closure of L, denoted L star. So L star, the Kleene closure, is the set of all x such that x is a concatenation of any finite number of strings in L. And remember that lambda is in L star. It's regarded as a concatenation of 0 strings in L. So a concatenation of any finite number of strings in L. So L is a set of strings. Choose any finite number of them, glue them together, and that is an element in L star. All of those glued together concatenations make up L star. Okay, so let's let L1 be the set of all strings consisting of an even number of A's. So that means it includes lambda, because lambda has 0 A's in it. It has no characters at all. AA or AAAA, where there's 4 A's or 6 A's. And then we're going to let L2 be the set B, BB, or BBB. So we're going to find each of the following. L1 concatenated with L2. So when you just put them next to each other, we read concatenation. So L1 concatenated with L2. So concatenation says that we are just going to concatenate elements from L with elements from L prime. So elements from L1 with elements from L2 are going to get glued together. So elements from L1 are strings of A's, strings of even numbers of A's, and we concatenate that with any element from L2. So I'm just going to start listing them, right? So, and then we'll describe it with words after. So let's list some things in L1 concatenated with L2. So we take an element from L1, say AA, and we concatenate it with an element from L2, like B. And we could concatenate with any element from L2. So I'm going to do AA with B, AA with BB, and AA with BBB. And then I can also choose any element from L1. So I randomly chose AA, but I could have chosen to use 4 A's and a B, or 4 A's and a BB, or 4 A's and 3 B's. Okay, so it looks like the pattern is I put an even number of A's followed by a B, 2 B's, or 3 B's. So I could just express that in words. So L1, L2 is all strings made up of an even number of A's followed by B, BB, or BBB. Okay, now the union of L1 and L2. So that is, the union is where you take all the strings from L and all the strings from L prime, and we just put them together into one big set. So all the strings from L1 and all the strings that live in L2, and we put them into one big set. So this is going to be the set of all strings made up of an even number of A's and B, BB, and BBB. All right, let's think about L1 union L2 star. So remember, we have to remember what star means. We already know L1 union L2. That's the union of just all the even numbers of A's, string, and B, BB, and BBB. Okay, so if I want to do the closure of that union, the closure, L star, is the set of all X such that X is a concatenation of any finite number of strings in L. So I can concatenate or glue together any strings that show up in the union L1 union L2. So let's start listing some elements that are in the closure. So I can concatenate anything from L1 or L2. So I could do an element from L1 would be AA and concatenate that with another element from the union, which would be maybe AA, which is just 6 A's. Okay. Or let's choose another element from L1 like AA, and then we're going to concatenate that with BB. Now, L1 union L2 is saying that I'm going to, the closure of L1 union L2, so the elements are a concatenation of any number of strings in L, and it doesn't matter the order, right? Just pick any strings and concatenate them. So I could also start with the B's. I could do B concatenated with 2 A's. I could do BB concatenated with BBB concatenated with A, right? So I had this element from the union, this element from L1 union L2, and then this element from L1 union L2, and I just concatenated them. You can take any finite number of strings from L1 union L2, glue them together, any order. So let's see if I can describe in words what these all look like. So Here I have no B's. I have 2. Here I have 1. Here I have 5. I could make any number of B's, right, by concatenating B, 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 and B, B, B. I can make any number of B's I want in a grouping. But my A's, whenever they get grouped together, they always come out even. So to describe this in words, I would say it's the string or the set of strings of A's and B's where every occurrence of A is in a even block, is in a block consisting of an even number of A's. Another definition, if we're given an alphabet sigma, we're defining something called a regular expression over sigma. So the empty set, the null string, and each individual symbol in sigma, in the alphabet, are regular expressions over sigma. And then we can define more regular expressions by concatenation. R or S, that vertical line denotes either one of the strings R or S. And R star, which is the Kleene closure of R. So R star, R is a string. It denotes the concatenation of R with itself any finite number of times. So the order of precedence, which is also known as the order of operations, among the regular expressions over sigma is as follows. So these are my regular expressions. The closure, which is when you concatenate a string with itself any finite number of times. Or either of the strings R or S, and concatenation, RS. So the order of precedence is the closure, concatenation, and OR. So I want to look at this regular expression to emphasize the order of operations. So here, A and B are elements of the alphabet sigma, and this is just a way of explaining how to make strings of A and B. So the order of precedence says we start with the stars or the closures. So I'm going to put parentheses around my stars here. So I have B star, parentheses there, and another parenthesis around this B star. Okay, and then the division is last. I'm sorry, the OR symbol is last. So I'm going to put my A here and do that. And then put an A here and block those together to make it real clear that you do the star, then you do the concatenation, and finally you do the OR statement at the end. All right, now here I have one written and I used a lot of parentheses to make it really clear, but I don't need them all. So I'm going to take out as many as possible and just rely on the order of precedence. So B star and A star should not need parentheses around them. So I have B star C. So that's going to do B star and then concatenate with C. And the last thing I want to do is the division, but these parentheses right here are indicating that I should do that or statement before I do this concatenation. So I'm going to do A and the or statement, and then I want to concatenate with A star. So that was the only set of parentheses I needed to preserve to make sure that I did this before I concatenated with A star, as the parentheses indicate. Given a finite alphabet. Okay, so alphabet's just a list of symbols, like A, B, C to Z, right? That's an alphabet. Every regular expression over the alphabet, so that's what we were just talking about on the previous page with concatenation, the closure, and the or piece, okay? All of those regular expressions over the alphabet defines a formal language. And remember, a language is just a set of strings over the alphabet. Okay, so the function, we can define a function from the regular expression to the formal language is defined here. So we say the language of the empty set is the empty set. The language of the null string is the null string. The language of any element A is just the set A for any A in the alphabet. And then if L of R and L of R prime are the languages defined by the regular expressions R and R prime over sigma, then we can say, well, the language of R concatenated with R prime is the language of R concatenated with the language of R prime, and the language of R or R prime is just the language of R unioned with the language of R prime. And the language of R star, the language of the closure of R, is the language of R starred. So let's do an example with this. So I have a basic alphabet, just the letters A and B, and I want to consider the language defined by the regular expression A or B star. So A or B, and then the closure. And I want to use set notation to find this language and describe it in words. So I'm looking for the language of this expression A or B star. And now I'm going to use these rules about languages to see if I can simplify this. So the first rule I'm going to use is the one about the star, because order of precedence says deal with the star first. So the language of something star is equal to the language of the something all starred. So this is going to be the language of A or B starred. And then the language of A or B, that is the language of A union with the language of B. And then remember, all of that is still starred. And then I have this rule that says the language of an element is just the set with that element in it for any element in sigma. A and B are both elements of sigma. So this is, the language of A is just the set A, unioned with the set B. And I want to take the closure of that. And then set A unioned with set B, that is the set AB, and take the closure of that. And then remember that star, that closure, means the concatenation of any finite number of strings in the set. So the concatenation of any string made up of A's and B's. So I could write this in words as the set of all strings of A's and B's. any finite concatenation of these elements is just going to be a string with A's and B's in it. And this is, we could write this as sigma star. Right? If you go back to the beginning of the lesson, sigma star meant the set of all strings over sigma. So the set of all strings made up of A's and B's. So we're going to use this particular notation a lot, this A or B star. And we have to remember that means the set of all strings of A's and B's. And that's how we're going to, this is how we get there. But we're going to use this a lot in this lesson and the next. So for example, if I have sigma is 0, 1, so this is my alphabet. Those are my only two symbols, zeros and ones. I want to use words to describe the languages defined by the following regular expressions over sigma. So I have to be careful of the order of precedence. I have to do the or part last. So 0 star, that is, remember, the concatenation of 0 with itself any finite number of times. Okay, so this is 0 star is just a string of zeros, any finite number of times. 1 star is a string of ones. And then we'll say or a string of ones followed by a string of zeros. So this looks like 0, 0, 0, some number of zeros, followed by some number of ones, or some number of ones, followed by some number of zeros. In this case, again, we do the order of precedence, which is this, we'll do what's in parentheses, then the star, then the concatenation. So 0 or 1 star, that's of this format, A or B star. And this A or B star meant the set of all strings of A's and B's. So this 0 or 1 star is the set of all strings of zeros and ones. And then that's going to be concatenated with 0 on the front. So this language is really the set of all strings of zeros and ones that start with a 0.